Hey everyone, this is Mr. Gunnell. I wanted to go through a quick tutorial of Vernier video physics. I know that some of you are planning on using that app for your individual investigation, and it's a little tricky if you haven't used it before, so I thought I should show you a few things. The app looks like the one at the bottom left is the second one right next to FET, and so I'm going to open up the video physics app. And the first thing you can do, you can either take a video directly in the video physics app, or actually what I would suggest is to just take a video using your camera, and then you can import it into Vernier Video Physics. So in the top left corner, you can see that you can choose an existing video. So I've actually uploaded one from actually one of my college labs. You can see it's way back to 2005. This is a lab that would have been actually much easier to do with video physics. We had to plot all of our points by hand, but this should be much easier. So I'm going to pick that video, and then this was a lab where we used a projectile launched across the room. I'm going to move through the video, and you can see at this point it starts flying across the screen, and we can watch that projectile go back and forth as I'm moving through the video. So I'm going to go back to the first time I see it. I actually don't really care about anything before when I see the projectile because it was just sitting in the Canon. The video had started a few seconds before, and so I'm going to look at each individual frame of where that ball moved to. So this tool allows you to move around and track where the object is. Now, if you look in the bottom right corner of the screen, I just tapped on the screen to get this back. There's a button called track in the bottom right corner. That sometimes works for some people and sometimes not. So as you're tracking the motion of an object, you're going to use this tool to move it around. And again, I'll get that back so I can see the first time that it comes out, and I'm going really slowly frame by frame, and I'm just going to move it back until I see that first dot coming out of the Canon, which I think is right there. And then I'm going to move this over to that projectile. And if you have a big enough object with a plain enough background, you might actually just be able to let the object track, and it'll follow it through the entire video. So if you have it at the first location and you click track, it should track it, but you can tell that all those dots ended up at exactly the same spot. Couldn't see the projectile, so we're gonna have to undo that. So I'm gonna move off of here and click those dots. And the easy way is to do select all and then delete all the dots. So I'm gonna go back and redo this. I'm gonna scrub back to through the video to where this actually started. And then instead of using track, I'm gonna move the crosshairs over to the object, and I'm gonna just tap on it once. And as soon as I tap, it moves to the next frame in the video. So then I go find my object again, and I'm going to tap on that. And then same thing, every time that I click, it moves through the video, and I just have to go find my object again. Now you want to be careful about this. I'm going a little quick. I think we should be okay. This is still much faster, like I said, than doing this by hand. When I was doing this as a college lab, what I had to do, sometimes you can't even see it. What I had to do was plot all the points as X and Y values. I think I can see it. It's a little hard to tell. It's actually pretty cool because you can see the trajectory of this. It's really nice and parabolic. This was launched from a little Canon at an angle. And I'm gonna wait until it gets off screen. And there's the last one. You can still see it off screen, but I'm only going to do it while it's in front of the grid. Of course, you don't need to use a grid in your lab, but one thing you do need to do is in your videos, and you should make sure you do this before you take any video, is that you have to, excuse me, you have to know somewhere in your video that there's a meter, because we just did all the points. If I was just to do the graphing option up in the top right corner, notice that when I'm doing this, it's giving me everything. If I look at my axis labels, it's in px, that's in pixels. Because without some reference, this app doesn't really know what a meter is. So while you see points up there as highlighted, if I tap on origin and scale, I need to tell it what a meter is. Now, I picked this video because in this, basically this grid is mapped out to a I believe every box is, let's see, it looks like 5 centimeters. So I'm gonna mark off what a meter is. It could be anywhere really. Actually, it looks like every box is 10 centimeters. So I'm gonna set the scale there, and in this video, that's 1, 2, 3, 4, 5, 6. That's 10 boxes, and again, each one was 10 centimeters. I misspoke before. So that length I've had to set so that it knows that 113 pixels on my screen is exactly 1 meter. Now there could be other options here. In terms of like, you don't have to set it as exactly 1 meter. If you know it's something else, then you could do that. My suggestion would just be easier if you do as a meter. I actually don't even know really how to change that. So once you've set that, we can even look back at our points. But if we look at the graph again, now our units have changed from pixels to meters if we look in those axis labels. Now if I swipe to the left, we're going to see that that's actually really nice. For our X location in meters, we get a nice straight line. Our X velocity is kind of jumping all over the place, but notice that if you look at the Y axis, it's still really staying right about 3.1. So those small fluctuations, it's not actually showing the entire graph. Those small fluctuations show me that it's actually staying at really about 3 meters per second the entire time. Those changes are really only because of where I clicked and that there is some uncertainty in where you're clicking. If we look at the Y location, that's a nice parabolic graph because in the Y direction it's accelerating. And the Y velocity is a nice constant slope because it's accelerating at a constant rate in the Y direction. And that's all 3 of the graphs. Now, the other thing that we can see here too, notice that my X axis or my X graph doesn't actually start at 0 for the X position. It starts at like a negative something. So one other thing you could do on origin and scale is notice that this X and Y, we can move it around to where our origin should be. So I'm actually going to set that right where it comes out of the cannon, right where my grid is. And if I go back to the graph, that'll correct the X-axis, so it's starting from the origin. That's a really nice straight line. Again, same thing with a Y. And so we're seeing that it goes up and back down. So hopefully that helps you with using the Vernier video physics app. I know it can be a little confusing at first, the first time you use it. Once you get a little practice, it should be just fine. And good luck.